everybody, this is Fouch Family Off Grid. We are making progress on our goals for 2018. Today, Nick is going to give a tour of the first joinery of 2018. This is the main beam for the mudroom.
Okay. So this is the main beam for the mudroom. Main just meaning it's the only one of its kind. So it's the long side of the mudroom. Runs parallel to the house, and it joins into two corner posts, which are the front corners of the mudroom.
For the sake of everyone's enjoyment, I'm going to fill in some of Nick's vocabulary. I am not the timber framing expert, I'm not even the carpenter, but by saying out what some of these things are, I hope to include all the people in timber framing and carpentry skills. If I can understand it, anybody can. So when Nick talks about joinery, that's simply two pieces of wood being connected in a permanent way. And when he talks about the mortise and tenon, that is a slot and tab. The tenon is the tab and the mortise is the slot. So what you're looking at right here is the mortise, the slot, and this right here is what he calls the housing. The whole diagonal knee brace is going to connect here, but the tab is going to go down into this slot, but there's also the rest of the knee brace connecting here, so that increases the bearing surface. There's weight coming down here, and there's also weight coming down here. Here's an example in our house. The beams are the ones going side to side, the posts go up and down, and the knee braces are on the diagonal. And that is the beginner's explanation. Now we'll hand it back to the expert.
I learned what's called square rule timber framing, and it's just a method of measuring and a method of working that assures accuracy. So there's a lot of different ways to do that, but this particular method has a beam size and then a true beam size. So you're always assuming that the beam that you're working with is a little bit bigger than the actual size that you need, and that way any variations in that beam are taken out by reducing down to your true beam size, and that you only do that at joinery. You're reducing down to that true size at joinery, and then everything else can kind of run wild, and you don't have to worry about having a super straight, true beam. You just address it at the points where it matters. So this being cut on the bandsaw mill, not just mine, but all of them, it's gonna wander some. I wanted this to be 8.5 inches. Well, it took a little dive down at this end, and it's not quite 8.5. Out here, it's pretty good, 8.5, but that doesn't really matter because my true beam size is 8. So that's what that reduction is all about. So I reduced that down to a true 8 from my reference edge. You start by picking a reference edge, usually the top and outside. So that gives you a corner that you're always measuring from. Since I'm working with rough cut, I don't always know exactly what the width of the piece is, but I need to keep a consistent reference that I'm measuring from. So whenever I'm measuring the depth of a pocket or a mortise or anything, I'm always measuring from this corner right here so that it's consistent. And I put that right on the drawing. That's the reference side. That's the reference side. So I always know where I'm pulling measurements from. When I do the drawing, I don't pull a measurement that isn't from a reference side. So I know that I'm measuring that. Rather than the depth of the mortise, I'm measuring what's left. So you're always taking measurements from those sides. So this is my outside, this is my top, this is my reference corner. I would measure down from there rather than saying I know that I want to reduce it a 1/2 inch down to 8 because this isn't really a good starting place. That's not my reference. That's my reference. Okay, so normally if my beam is nice and straight and not twisted, you'd just be able to take that reference edge and run with it. Run all your measurements off of that. I milled these beams back in May. So they've been sitting around for a while, and has this one in particular, because it's about 12 feet long, has a bit of a twist to it from one end to the other. So if I were to just take that reference edge and measure those tenons and mill and cut them relative to that edge, well, one would be this way and one would be that way. And then when I go to put them into the posts, that would make this post go that way and that post go that way. And no amount of trying to force it into plumb would really work. It would cause some damage. It would most likely crack either the mortise in the post or it'd mess up the beam. In any case, the housings wouldn't sit flush and your bearing surfaces would not be touching. So what I do, and what I had to do a lot on our house, I'll set up my beam so that it's so that it doesn't move, and level it with my torpedo sort of in the middle and make that level. Then I'll come to the far end and say, it's that far out of level, and I want to look for about the same out of level in the other direction at the other end, so that I know that I'm averaging that twist, so that one end is just as screwed up as the other end. And then I'll lay out this tenon using a level running plumb, and then that side running plumb. And then I know that those two tenons are actually cut coplanar with one another. It makes some of the joinery look a little ugly in that you're aware of that twist, but it makes it work. And your tenon will be truly plumb. And then if you're able to cut square to that, your housing, your bearing surface is going to be truly level and will rest on the proper place on that post. And that's more important than everything looking super flush and beautiful on the inside of your building. So this beam really doesn't have a lot of joinery to it. I'm not doing rafter seats in the top of the beam. I'm going to bird's mouth the rafters to go over it rather than spend all the time doing seats in the rafter. So it just has this tenon and its reduction, and then it has a mortise for the knee brace. So this is upside down. There's a post coming from here, knee brace coming back to here. This knee brace comes in at a 45. An easier way than actually doing your mortise at a 45 in there is to go ahead and do a square mortise and just remove more than you need. The most important surface on the knee brace mortise is this bearing surface right here. So there's pressure being applied to this face, and all of this. Not so much at the bottom of you make your mortise deeper than it needs to be, so there's no contact at the bottom of your mortise. These are the bearing surfaces here. And so that has to be, well, it can be whatever you want to make it, but it has to be the exact number off of your bearing surface over here. So the correct distance off of the post. So if you know that distance, and you know then the distance from this surface to where the knee brace goes into the post, those are really easy to lay out, and it's nice to make that an even number. Then you got to do a little bit of math, or draw it, and figure out your hypotenuse from the long point of the knee brace to the other long point of the knee brace. And then when you're making that knee brace, you need to double check that, because that's what's going to make your building square. So what did I do to turn this piece of wood that used to be a tree into what you see here? The mortises are done with the chain mortiser. It does a really great job of getting through the bulk of the work quickly. There's usually some cleanup to be done with a chisel, and I do that on purpose. I go just a little bit off of the line so I can tune in the width of that mortise with the chisel, but it really makes what would otherwise be a really sort of labor-intensive job of removing all that material. It makes it go really fast. With a project this size, it really wouldn't justify the cost of a chain mortiser, but when doing the house and thinking about additions later on and more timber framing that I would like to be doing, it really made sense to go ahead and pony up the money for the chain mortiser. Then the housings, which is anytime that you see sort of a surface reduction right there. The housings I do with a router, and I will normally make a jig for it, just a capture jig that lets me see my layout line, put it down over the layout line, and then know that the router's going to cut to that line. With a twisted beam like this, I go ahead and take the time to put a level on both of those tools for the same reason that I put a level on the tenon. The tenons are mostly cut with circular saws. So I use the beam saw for anything that's over like 2 inches deep, because my circular saws will only go 2 and change, 2.5 at best. A lot of the time with the beam saw, I will set it just a little bit shallow and finish off with the pull saw, just to avoid cutting too deep. You don't want to risk it and cut too deep. The beam saw is an awesome tool, but it is not exactly a precision tool. You can get it to do things well, and it's really ideal if you can kind of get it to do it in one shot without a lot of trimming and tuning of faces, but it's a big tool that's hard to really put it exactly where you want it. So I tend to just sort of stay back away from the line a little bit as far as depth, and then finish off with a hand tool. The reduction here and this little chamfered edge, that was all chisel work, just to hone down to my ideal beam size. And then this other cut here, that was the hand saw as well. So I cut both of these, both of those, and those removed, and then that and that are with the hand saw. And then once everything's cut, I'm just sort of making the rounds with the framing square to make sure things are square to my reference face, square to each other, and that the mortises are as clear as they need to be. The framing square, which is pretty common, I believe is made the way it's made because of timber framing. There's an 1.5 inch width, there's a 2-inch width. And those are common mortise and tenon sizes. So I have 1.5 inch mortise and tenons on this project, so I can use this for layout of things that are supposed to be 1.5 inch wide. Layout of that, its housing next to it. But then I also, once I'm done cutting, go to check the mortises by putting this end in there. And I just check that it actually makes the swing across there. There's nothing that's going to stop it. If I can't get it all the way in there, then I work on it with a chisel. So I've also made a little tester for the tenons as well, and that was just done by, it's an 1.5 inch wide slot in a piece of wood, and that just helps you to see how well you've done at your tenon size. So those are good little safety measures to keep you from getting the chisel out too much when it comes to assembly. So the only thing that's left to do is I'll take off these edges just a little bit, and so that they're easier to start into assembly, and then I seal all of the end grain with liquid wax. The brand name is Anchor Seal, and it's for end grain sealing on green wood. So this is still drying, and you need to slow down that drying by sealing your end grain. And I have a lot of exposed end grain, not just there, but the end grain that you see in all of these places. That is where the moisture is going to run out, and you want to slow it down so that your beam doesn't change shape too dramatically. So that's the main beam of the mudroom. Come on back, we're doing more parts, and eventually we'll put this thing up.